Good morning, all. Myself, Mishaha, Department of CSC, Vedavyasa Institute of Technology. Topic is NetBAS Transaction Behavior Tracking. NetBAS is a BAS platform developed to improve the current BAS platform, providing a more convenient and safer development environment for developers. So the performance has been one of the important issues in various blockchain systems and becomes a major constraint of its application since the emergence of the blockchain. Current blockchain system, whether public blockchain or consortium blockchain, suffer from various performance problems, especially when executing complex smart contracts. So the application and limitation of smart contracts for IoT indicating that the efficiency is too low to execute the contracts on IoT. All of these applications have the same problem of long execution time and low efficiency, which make them still unable to replace the centralized solution. Then performance is one of the key factors restricting the application of blockchain-based smart contracts. Real-time performance monitoring of a blockchain network is urgently needed, which can help developers to find out the mistakes when the system is abnormal, as well as optimize the corresponding peers according to the result of the performance analysis. So they mainly focus on monitoring the overall transaction situation of the whole network, such as transaction throughput, average time to complete a transaction, then transaction confirmation delay, and so on. Overall metrics cannot reflect the detailed performance at different stages. That means once the network is abnormal, it is hard to pinpoint which stage of the transaction has an impact on the system. So normally all peers are treated as the same role in the system, but in Hyperledger Fabric there are several different roles of peers which are responsible for different tasks of transaction processing. So this is not fully applicable to Hyperledger Fabric. It cannot monitor the service invocation and time consuming situation of a transaction at different stages. This figure shows 4 stages to reach a transaction in Hyperledger Fabric. The first stage is endorsement according to endorsement strategy, and the second one is committing the transaction to Fabric orderer. After sorting the transactions, Fabric orderer will package all transactions into a block and then transmit it to leader peer. Then the leader peer will synchronize this block to other peers in the same channel. In order to monitor the service invocation and time consuming situation of each stage, here developed a gRPC or gRPCS tracking interceptor based on Jagger. Then the transaction and blocks are transmitted between different peers through gRPC or gRPCS. So here a tracking interceptor between gRPC server and gRPC client is installed. When the endorsement peers, the orders and the ordinary peers are interacting with the gRPC, then the tracking interceptor can collect the context information for service invocation as well as transaction information. All information is transmitted to our system as a source of data for our analysis of system performance or exception. There are 4 collecting points for tracking information from generation to entry into NetBAS system that are shown in figure. Right, Jagger agent, Jagger collector, then Jagger client, and finally data store. Those are shown in figure. First, Jagger client is an open tracing complaint SDK is implemented for different languages through the API provided by the SDK. The gRPC interceptor writes data to Jagger client, and then the client passes the tracing information to the Jagger agent according to the sampling strategy specified by the application. Then Jagger agent is a network daemon that listens to receive span data on a UDP port, and it sends data to the Jagger collector in batch. The next is Jagger collector. It receives data from Jagger agent and then writes the data to the backend stage. The final one is data store. Here we using a elastic search, that is a distributed restful search and analytic engine capable of solving a growing number of use cases for storing log information. Users can query real-time log information easily through a set of RESTful API.